The 420 format is a type of chroma subsampling used in image and video compression. It's a way to reduce the file size of images and videos with minimal visible loss of quality by taking advantage of the human visual system's lesser sensitivity to color detail compared to brightness detail. To explain this concept, let's break down the components of the 420 format, focusing on a 4x2 pixel block example. The 4 in the 420 format refers to number of Y samples in each row. For every 4x2 block of pixels, all pixels in each row will have their Y component or brightness fully sampled. This means each of the 8 pixels in this block will have its own unique Y value. This is because our eyes are more sensitive to variations in brightness than to variations in color, so maintaining full resolution in the luminance information is crucial for preserving the perceived quality of the image. The 2 in the 420 format refers to the number of CB and CR samples in the first row. For the chrominance components CB and CR, the 420 format samples these at a lower rate. Specifically, for every 2 pixels in the first row of our 4x2 block, only one CB and CR value is recorded. This means that in a row of 4 pixels, only 2 sets of CB and CR values are sampled. The chrominance information for the 2 pixels is averaged or shared between them. This reduction is based on the principle that the human eye is less capable of discerning the fine details in the color information of an image than in the brightness detail. The 0 in the 420 format indicates that there are no CB and CR components sampled in the second row. In the 420 format, the chrominance sampling is further reduced by not sampling the CB and CR components for the second row of pixels at all. Instead, the CB and CR values obtained from the first row are used for the second row as well. This means that the same CB and CR values sampled from the first row are applied to the corresponding pixels in the second row, effectively spreading one set of CB and CR samples over a 2x2 block of pixels. Effectively, in a 2x2 block within our 4x2 example, we end up with 4 unique Y values, one for each pixel, but only one CB and one CR value shared among all 4 pixels. In summary, this method significantly reduces the amount of data needed to represent the color information in an image or video, allowing for more efficient compression without substantially impacting the perceived quality for the viewer. By focusing on maintaining full luminance detail while reducing color detail where our eyes are less sensitive, the 420 format achieves a good balance between compression and image quality.